Okay, we'll solve the next problem. The next exercise tells us determine the cross-sectional area of the beam, A in square meters and B in square inches. So square meters and square inches. So when we're talking about an area, we talk about a distance to the second power. And the first thing that we have to notice is the shape of the beam or whatever we're trying to get the area from. So as you can notice here, this beam is divided or made of by three rectangular shapes, in which the first one, which is this one, is exactly the same as the third one, which is this one. And the second one is different from the other two. So an area of a square or a rectangular shape is going to be equal to the base multiplied by the height. So this is going to be my base and this will be my height. So the area of the first shape will be 40 millimeters multiplied by 200 millimeters because of this measure and this measure. And then I'm going to multiply this result by 2. Why is that? Because as I said before, this shape is exactly the same as this one. So I just gotta multiply that by 2. So the result is 2 times 2 times 4, which is 16. And then I add these 3 zeros. 2, 3. The answer is 16,000 square millimeters. Then the area of the second shape, I'll call this as A13 because are exactly the same. Of the second shape will be 40 millimeters multiplied by 120 millimeters. Then the result is 12 multiplied by 4, which is 48. And then I add these 2 zeros, square meters. So the answer is given by these 2 results added. So 20,800 square millimeters will be the result. Then I have to transform those into square meters and into square inches. So because of the square and because of these square millimeters, I cannot just change the position of the comma that goes right here, because as you can notice, this is equal to 0.00, and millimeters is equal to 1 times 10 to the minus third power. Maybe I should explain this more slowly. So when we have something here behind our unit, we have to check the equivalence between this prefix, because it's a prefix, and what quantity does that prefix represent. So there is a chart in which you can check, or you can Google it, that is named units prefixes. And in that chart you'll find the unit, and on the above part of the unit you'll find deca, hecto, kilo, mega, giga, tera, petahexa. And on the below part of the unit you'll find deci, centi, milli, micro, and nano, pico, femtodato. So that prefix represents a quantity. So deci is equal to 1 times 10 to the minus 1 power. Centi is 1 times 10 to the minus 2. Milli 1 times 10 to the minus 3. And starting from these 3, I'll add 3 by 3. So 1 times 10 to the minus 6. And the one that follows is equal to 1 times 10 to the minus 9, etc. And the same thing here, but with a positive sign. So 1, 2, 3, then 3 by 3, so 6, 9, etc. So as you can notice here, milli means 1 times 10 to the minus 3 power. So this, if I wouldn't have this square, if I have been talking about distance measure, which is millimeters, then I could change the direction of the comma by 3 spots. So I could just change this comma, which is this one, and move it here 1, 2, 3 spots. So the answer in meters would be 20.800 meters. But because of this square meters, then I have to use an unit conversion. So it is actually pretty easy. I just have to write 20,800 millimeters to the second power multiplied by. So I'll use this value. 1 millimeter is equal to 1 times 10 to the minus 3 meters. And because of these square meters, I have to evaluate this division with a second power. So the result is, let me check it in on the calculator, 20,800 multiplied by 1 times 10 to the minus 3. This is actually the same as this one. This bottom helps me to not write all the powers and everything. Divided by 1 to the second power. So the answer is 0.0208 square meters. And here we have our first answer. Then I have to transform those into square inches. So what I have to do is to do the same thing. I currently don't know the equivalence between meters into inches directly. What I do know is the equivalence between meters into feet, and then the equivalence between feet into inches. So that is what is going to happen. Then 1 meter is equal to 3.281 feet, and then 1 feet is equal to 12 inches. And because of these square meters, I have to evaluate these two divisions with a 2 as a power. So the result is 0.0208 multiplied by well, actually I don't have to write this the denominator because it is 1, so 1 to the second power is still 1, and a number divided by 1 is still this number. So 3.28, 1 to the second power, and then 12 to the second power. So the result is 32.2422 square inches. And that's how this exercise could be solved.